Okay, so this lesson I think is one of the hardest. It's combining transformations and then properties. So properties are like different things that happen when you rotate a figure, making it symmetrical, taking a transformation back onto itself. So our learning target is I can model and solve problems involving transformations. Okay, so this one's not too bad. The first thing we're going to do is we're going to combine a rotation and a size transformation, and then we're going to write one rule that kind of takes it from the pre-image to the very last A double prime, B double prime, C double prime. So the first thing I want you to do is I want you to plot and label the triangle ABC. Okay, so we have our ABC triangle. And number 2 says apply a rotation of 90 degrees counterclockwise about the origin and label the triangle. So I want you to make sure that you know what the rule is for 90 degrees counterclockwise. So go ahead and write it or look it up. Okay, so for 90 degrees counterclockwise, use the rule negative y comma x. So I want you to go ahead and do that to the points A, B, and C and go ahead and graph them. Okay, and I was going to edit that out, that I totally screwed up that first triangle, but then I thought it was important that you see that your teacher makes mistakes all the time. Anyways, okay, so I fixed the green triangle. Here's the blue triangle. Notice that it did go from one quadrant to the other, which is what we expect, and it turned, which is what we expect. So we have done number 1 and number 2. Now, number 3 says that we are going to apply a size transformation of magnitude. Anytime you see that word magnitude, that's the same as scale factor. So a scale factor of 2 to the triangle. So remember, I'm going to do it in a different color. This means that we're going to take xy, and we're going to do 2x and 2y, since the scale factor is 2. So I'm going to take the coordinates that we just did, A prime, B prime, C prime, and I'm going to apply a scale factor of 2. And now I'm going to write A double prime, B double prime, and C double prime, because I want to note that I've actually had 2 transformations. Okay, so go ahead and write out the new points, and you can go ahead and graph them as well. Alright, so it gets a little confusing when you put them all together. That's why I'm color coding it, so hopefully it helps you guys. So we have done step 3 also. So now what we want to do is we want to write a rule that translated the pre-image, that should say transformed the pre-image ABC to A prime, B prime, C prime. Okay, and we're going to write it in words and symbolic form, and I'm going to help you with it. So what I'm going to do is I'm going to write out the points that we had for A, B, and C, and then for A double prime, B double prime, C double prime. Alright, so we had points. A was at 1, 4, and then it became A double prime, negative 8, 2. B was at point 3, 1, and then it became negative 2, comma 6. C was 4, 3, and then it became negative 6, 8. So remember, so for our blue one, we had negative y, comma x, and then for our purple, we had 2x, 2y. So we want to come up with one rule that takes us from the green to the purple. So we know we need to start out with x comma y, and then we need an arrow for a transformation. And the last part's the hardest, I think. Okay, so use the fact that we did this at the very beginning. Okay, so we know we definitely switched the coordinates, and the original y was negative. But then the next thing that we did was multiply them both by 2. And now let's just check this to make sure that it actually works. So let's just look at A and A double prime. So A, we had 1, 4. The rule says that I'm going to take my y coordinate and I'm going to multiply it by negative 2. So 4 times negative 2 is negative 8. So check, that works. And then at the very end, I had 2 times x. 2 times 1 is 2, so that works also. And then you could just check with all the other coordinates. Just make sure that the rule you choose actually works with every coordinate, or that's not the right rule. Okay, so this is pretty difficult just writing it by yourself. These would normally be multiple choice questions. So you would have a bunch of options to choose from, and you could just plug in the coordinates and see which one works. Okay, so remember I said this was the most difficult lesson, so. Alright, so let's look at some other stuff. a lot of times these questions are going to ask about transforming a figure back onto itself. So whenever you see this is a question, it is asking, how would I make the transformation look exactly like the original figure? And obviously that should be a question mark. So you want it to look exactly like when you started. You want the same size, the same shape. You want it to be in the exact same spot, everything. So the transformation would not look like it had rotated, resized, reflected, or translated. It should be in the exact same place. Okay. Oh, already got some more typos. I see them. So rotation. This is say whenever a question asks about a rotation carrying back onto itself, and it is not a four-sided figure, you're going to use the formula, and I'm going to write it right here. The formula would be 360 degrees divided by the number of sides the object has. And it's either going to equal this or a multiple of that. So I'm going to show you what I'm talking about. So here's an example. Which rotation will carry a regular pentagon onto itself? So a pentagon has 5 sides. So 360 degrees divided by 5 sides is something. 72. So you would either be looking for the answer 72, which I don't see in A, B, C, or D, or you would pick a multiple of that. So a multiple would be like, what, 72 times 2? 144. I see 144, that's my answer. So anytime it talks about rotation carrying back onto itself, and it's not a four-sided figure, you have to use this formula. And remember, the answer is either going to be like 72 or a multiple of that number. And then I put down the bottom, just in case you don't know, if 360 degrees rotation is an answer choice, that's the answer. So a 360 degree is always going to bring back something onto itself. So if you ever see videos of when celebrities come out of rehab and they're like, I made a complete 360, that's bad. You're on heroin still. You wanted to make 180 and turn your life around. But if you're at 360, you're the exact same place you started with. Okay, so let's look at a four-sided figure back onto itself. Alright, anytime a question asks about transforming a four-sided figure back onto itself, choose an answer that has a line of reflection that goes through half of the figure. Do not choose a diagonal line unless you have a square. That's the only time it's going to work. So which transformation will carry the rectangle with vertices A, B, C, and D onto itself? So go ahead and graph A, B, C, D and label it and everything like you normally do. Okay, so we want to choose a line that goes through half of the figure. So if you choose this line, that line is a diagonal line. You can graph it in Desmos to see what it looks like. It's a diagonal line that doesn't even go through half of it. Don't pick a diagonal unless you have a square. B says a reflection over the line x equals 0. So x has to hit the x-axis at 0. See how that line goes directly in half? So if you were to reflect A, it would actually become C. And C would become A. B would be reflected to be D, D would be B. So it would end up looking like this. But do you see how it's the exact same figure? It's just labeled different vertices. It's back onto itself. B is the answer. If you were to rotate that 90 degrees, you would be in different quadrants. If you were doing 270, different quadrants. So don't pick a rotation unless you're talking about 360 or something like that. So pick a line that's going to go directly through the middle. Cut it in half. Alright, I hate this question. I'm just going to say it. So this is from a released EOC. And I don't know if we'll take an EOC this year, but just in case, you're going to be ready. Alright, so triangle EGF is graphed below. Triangle EGF will be rotated 90 degrees counterclockwise around the origin. And then it's going to be reflected across the y-axis. Which additional transformation will map the image triangle back onto the original triangle? So here's what you want to do. You want to take this triangle that you see right here. You want to rotate it 90 degrees counterclockwise. You want to reflect it across the y-axis. And then you're either going to do A, B, C, or D to get that exact triangle. So the first thing I want you to do is I want you to lift out the points, E, F, G. Alright, so we got the points. So now, we want to do 90 degrees counterclockwise. So that rule is negative y comma x. So I'm going to go ahead and write my new coordinate points using that rule. Alright, and then here I'm going to do this in green. Alright, and then I'm going to flip it over the y-axis. So you have to know that rule as well. That's negative x comma y. And I'm going to go ahead and write the new coordinates from purple to green. Okay, so that rule says that I'm going to change my x coordinates to the opposite sign, and I'm going to leave the y coordinates the same. So we didn't switch them or anything like that. So what I want to know is how to get these green points to look like this again. And if you'll notice, the only thing that's happening is the x and y need to switch place. The x and the y need to switch place. So if you look at the answer choices, which one has a rule of y to x? And it's this one. Because this one has this rule. So it's saying, if I switch those green points, they're going to be the blue points again. It's going to go back onto itself. I hate this question. I think it's really hard, but that's how you do it. Alright. So that was the end for that one, because I know this is really complicated stuff. Alright, let me know if you have questions. Try the practice problems. See what you can do.